Excuse me, teacher, you are muted.
So that you can work with me. Because I can't work alone. You know, mathematics
Hello,
is
yes,
for you to understand to work. Can you hear me?
yes, thank you, teacher.
I still hear people talking on the background. Whenever someone okay, let's do it this way. I will speak and you listen. After some time, we'll give you a chance to ask questions. Well, the problem now is going to take some time for all of us to work if we talk at the same time. So I'll talk alone, unfortunately, then I'll give you time to speak again. Thank you. Okay, our lesson, we will start with fraction. I'll do a little bit of fraction in today's lesson. Then tomorrow we'll do addition and subtraction of fraction. Today it's only introduction of fraction so that we can be all in the same page. So this is what we're going to cover in today's topic. We're going to cover proper fraction, improper fraction, mixed numbers, and equivalent fraction. And I know most of you think they all understand, but I want us to start with basics so that it can be easy for us to start with addition and subtraction. Okay, we'll start with proper fraction. Proper fraction is a fraction with the denominator bigger than the numerator. In the foundation phase, we say a proper fraction has a small head, meaning that the numerator is smaller than the denominator. A fraction can be represented as a number or a diagram. So we know that a fraction, all we do is we just, if we're doing a diagram, you have your square, you cut your square in maybe in 4. So you know that you were sharing with 4 people, so our denominator will be 4. So another thing that you should know about fraction, the denominator and the numerator will always be a whole number. When we talk about whole numbers, we talk about counting numbers. Your 0, 1, 2, 3, 4, 10, 20, 30, 40. It's a whole number. So your numerator will always be a whole number, and your denominator will always be a whole number. Okay, going back to proper fraction, we say you can represent your fraction in numbers or diagrams. The first one will do the number. I took the easy one, a half. So it's 1/2. You can all see that the numerator is smaller than the denominator because our denominator in that fraction is 1. Our numerator, I mean, in that fraction is 1. Okay, it's smaller than the denominator. Okay. Here is a diagram. Because here we have 3 cycles there. The first one is cut into half. So we know that a fraction is a whole number that is cut. Because we know that the whole cycle there, it's a whole number. So once you cut it, we have a fraction. So the first one is already written there. It's 1/2. So our numerator is 1. We say we are busy with proper fraction. Of this proper fraction, the numerator will always be smaller than the denominator. And then the next one, our circle is cut into 4 pieces. So our denominator will be 4. That's where we get the denominator. How many times did you cut your circle? 4 times, and then that 4 will be a denominator. And now we only highlighted one part. So that's why we have 1/4. So all we need to know in proper fraction is that the denominator will always be bigger than the numerator. I'm not going to ask you a question about the proper fraction because I know you did this in the previous classes. So I'm just reminding you, or I'm just refreshing your memory. Let's go to the next one. We will do improper. improper fraction. We're done with proper fraction. Now we're moving on to improper. The improper fraction is exactly we can say it's an opposite of the proper, because a fraction whereby the numerator is bigger than the denominator. Basically, an improper fraction is an opposite of a proper fraction. In foundation phase, because they normally use tangible things, we say improper fraction has a big head. So the kids will never forget if the improper fraction has a big head. I know we did this already. Same way, improper fraction as well can be represented as a number or a diagram. Okay, I have an example there. And I said this is how we write an improper. So we have 5/3. So meaning that the numerator is bigger. It's 5. In that case, the numerator is 5. Hello? Okay. Okay. So we're saying it's an improper fraction because it has a bigger numerator. In our example, we have 5/3. So it is 5. It's a numerator, and then my denominator is only 3. Okay, can you give me a second? I'm supposed to record this. Forgot now. Okay, thank you, I'm back. Okay, we say we deal with improper fraction that has a bigger numerator, and then it's an opposite of the proper fraction. Okay. Someone is laughing, but let's continue. Okay, this is how we represent diagram.
Stop laughing.
That was not true. Just do it. That's not true. But let's continue because I know some others are listening. Okay, here is a diagram of an improper fraction. The first cycle has been cut into 6, and then they all shaded. And then the second one is cut into 6 as well. It's only 2 that are shaded. So our denominator will be 6 because the cycle has 6 cards. So we count those cards, that will be your denominator. And then now we have 2. So we count, we have 6 that are shaded on the first one. 6 plus 2, then we have an 8. So our numerator will be 8. This is important. We're going to use this information when we're doing our addition and subtraction and our multiplication as well. So that's why I'm starting here, so that I can know that we are all in the same page. When we talk about improper fraction, we know that we can also change it to a mixed number. But now, the first one, it's cut into 6, as I said. And then the second one, it's also cut into 6 pieces. And then only 2 that are shaded. So meaning that now it's 6 plus that 2, and then we have an 8. Our denominator is 6 because our whole number was cut into 6 pieces. That's where we got the denominator. Okay, so let's add this together. Yay! The first one is 6/6. We all know now that 6/6 is equal to 1. Any number that divides itself, we know it's equal to 1. So it's 6 plus 2, we have 8/6. That's an improper fraction, meaning that the top part will always be bigger than the bottom part. So in math terms, we say that the numerator will always be bigger than the denominator. Okay. Here is another example. I don't know if you can see. Here we are given 4/3. We will write it as 4/3 because it's 1, 1, 1, 1. So that's 4/3. That's the first one. The one that is in yellow. Can you see on the slide? The one that is yellow, those are 1/3, 1/3, 1/3, 1/3. So if it was a circle, we'll have 3 circles. We have a circle that is cut into 3. So it's only one that is shaded. So it's 1/3, 1/3. So if we add, we have 4/3. And then the next one is still the same thing. Okay, so this is what we learn now, that the denominator of an improper fraction is less than the numerator. In other words, the numerator is bigger. Now
Okay.
let's move away from a concrete to abstract, since you guys now in grade 7. We did this already, as I said in the beginning. Let's see how we can convert from a mixed number to an improper fraction. Next, this is how we do it. We're changing a mixed number to an improper fraction. Okay, that's a wrong slide, but we'll continue. Let's say we have 7 and 1 over 4. So on this question, I gave you improper fraction instead of giving you mixed number, but let's work with what we have now. Okay, we have there an improper fraction, that is 29 over 4. Let's say now the question says, convert it to a mixed number. A mixed number, we know it's a whole number and a fraction. It's a whole number and a fraction. Let's go back to that. This is the diagram that I had earlier. This is a whole number that the whole circle is all in yellow. So all 6 of them has been shaded. So it makes it a whole number because it's 6 over 6. And then we said if the number divides itself, it's a whole number. Okay, let me go back to what we were working on. We have 29 over 4. The question says, convert the improper fraction to a mixed number. All you do, you divide, because 29 over 4 is almost the same thing as 29 divided by 4. So you ask how many 4s goes to a 29. So I know you know your multiples. 400 How many 4s go to a 29? I'll give you an answer because you're all muted. The answer will be 7. So what will be the remainder? That's 1. So you take that 1 and over 4. So you have a mixed number of 7 and 1 over 4. So meaning that if it was, we were doing in a diagram, we will have 7 cycles all cut into 4 pieces. And then the last one will be cut into 4 pieces. I don't understand. Only 1 will be shaded. So let me say it again. Okay, let me say it again. If we were writing it as a diagram, because our denominator is 4, you will, how we said, we have 29 over 4. We're changing it to a mixed number. So I'm saying the answer would be 7, 1 over 4. So how many 4s go to a 29?
7.
That's 7. Next?
Yes, I agree.
7,
It
14,
is
29.
7.
7, 14, 28, sorry. Come again?
I only asked it if it was 7.
Talking. I want you to unmute. Come again?
It's 7.
So we're saying 29 divided by 4
7.
is
It is 7, ma'am.
So the
7.
remainder will be
7.
1. So I'm saying now, let's
7.
write the remainder.
It is, I think it is 7. There is 1 remainder.
7. 7. 7.
It's 1.
Oh.
7
Oh.
times 3.
How's it going? Oh,
7 times 4.
Con nhiều.
Times 4 is 28. So the remainder is 1 because it's 29 over 4. So I'm saying, let's write this diagram. Next, I'm saying, let's write this diagram. So we have, let's use this cycle. We have 7 cycles. Next, we all cut them in 4 pieces because our denominator is 4. Okay, someone is talking? Yes. So the answer will be 7 and 1 over 4. Okay. I'm saying now, let's try to write it in diagram. We can all know that we understand. I'll say we will have 8 cycles. All 7 of them will be all shaded. The cycle will be cut into 4 pieces and then all 7 of them will be in shaded. And then the last one, only 1 will be shaded. You can all see that the whole numbers, there are 7 whole numbers, and the last one will be a fraction. Okay, let's continue. I'll take questions later. Okay, let's continue. The next one, we have 17 over 2. So we ask how many 2's go to a 17? There are 8, and then we left with 1. So the answer will be 8,
1
1,
and 1.
2.
One
And then we do the third one. I'm not going to do the last one. We do the third one. 13 over 5. We all know those improper fractions because the numerator is still bigger than the denominator. So we have how many 5's goes to 13? It's 2 and then the remainder of
3
3. So we have 3 over 5. Those are all improper fractions. The number is 2,300. Yes, thank you. Put this on your own. 64 over 10. I'm not going to do it with you.
Okay. 6 whole number 4 over 10.
Let me continue.
6 and 4
over 10.
Thank you. Thank you. Let's continue. Now that we know what improper
Nee, die
fraction,
support nee.
okay. Okay, let's
Mammy muted. Hello.
4 over 10. Is that correct?
Yes.
We say 64 over 10. I can see all of them is still there, so I went back so that we can just finish it and go forward. We have 64 over 10. How many tails go to a 60?
6.
You don't know your multiples. Okay. Someone is raising hand.
And
You
going.
can answer.
Continue.
Okay. So
Martha, are you talking?
I'm muted people.
it's equal to 6.
Okay. And I'll give you the answer.
6 whole
4
number 4
over
over
10 is equal to 6 and 4 over 10. But we have to simplify that 4 over 10.
10. Rainbow. He came and test. So later.
Yeah, all right.
It's equal to 6 over 4.
Martha, we can't hear you. You
6.
can't hear you.
Remainder 4.
Okay, it's equal to 6, remainder 4.
Thank you.
I can't hear. So I want to be. They don't like maths.
You can hear the Oh, you know, it's music from different places. People are not used to this. Come.
The host unmuted all participants. So
Wenzela
Ladies and gents, I
plan.
keep on muting you guys. We keep on unmuting yourselves. Can we please have everybody just keep yourself unmuted while Uleka takes over this class. Then once this is over, you will get time to ask questions, okay?
This teacher muted and now everyone's speaking at the same time.
What happened?
I told
Has just lost connection. She's busy joining back in. If everybody can just give her a moment, please. Thank you. I will be back just now. Sorry about this. She's just having some connectivity issues.
Hello? Sorry, man, I'm back.
Class.
Sometimes.
I have muted the learners. I will unmute when there's a Q&A.
Okay. Can I
Continue.
continue now?
Yes, you can.
Thank you so much. Okay, my apologies. Hope that won't happen again. Okay, we were busy with 64/10, and then we all said that the answer will be 6 and 4/10. And remember, you cannot leave 4/10. You need to simplify it. So the correct answer will be 6 and 2/5. Okay, let's continue. Mixed fraction. Here is just an example of mixed fraction. You can make it an improper fraction the same way as a mixed fraction in diagram. For example, number 1, we have 2 circles all cut into 4, so our denominator is 4. The first one is all shaded, meaning that all 4 pieces are shaded. So it's a whole, because 4/4, answer will always be 1. If the number divides itself, the answer will be 1. If it was million, answer will always be 1. That is a whole number. So it's the same example. For example, number 3, we have 3 circles, they all cut into 6. That's how our denominator is 6. So the first one, all shaded. The second one as well, all shaded. And then the last one,
I'm back, but I won't have slides now because I'm using my cell phone. Let me apologize for that.
Can you all hear me?
Continue.
Okay then. Okay, you won't have a slide, but I will continue with the lesson because my network is failing me. Okay, good. There are two strategies. We were busy with that 64/10, and then we all agreed that the answer would be 6/2/5. So let me give you two strategies where you can convert from mixed number to an improper fraction. We've been converting now improper fraction to a mixed number. So now I want us to start from a mixed number to an improper fraction. I'll give you an example. So you have to use your pen because I do not have a slides in front of me. So I'll use your pen. Write with me. The first strategy, let's say you're given a question like this: 3 and 1/2. In other words, 3.5. You're going to write it in fraction. So you have a whole number of 3. And so 3 and 1/2. So you're going to do the strategy how you can change your your mixed number to an improper fraction. Because in the previous slides, we were busy with improper to a mixed number. So here is the question. I'm using the easy question so that we can understand. We have 3 and 1/2. So we're changing it from mixed number to an improper fraction. So we said earlier on, if you remember, if the number divides itself, it becomes equal to 1. For example, if you have 4/4 will be equal to 1. 10/10 will be equal to 1. So now I want us all to write 3 in fraction. With 3, the 3 I'm talking about, the one that is a whole number. So I said our question will be 3.5. That is 3, 1/2. So let's all write it down. We write 3 in fraction. We'll have 2/1 plus 2/2 plus 2/2 plus 2/2. Remember, we said the number, if divides itself, will always be equal to 1. So if we have 2/2, we know that's a 1. That's the first one. Plus 2/2, that's another one. Plus 2/2, that's another one. So we have 3, because 2/2 is a 1, and then 2/2 is a 1, and then 2/2 is a 1. So if you add all of them, we have 3. So we wrote the whole numbers as a fraction. And the last one will be 1/2, because it's a half. So if you write, we have 2, we're only adding our numerators. So we have 2, 2, 2, 2, and 1. So 2, 4, 6 plus 1. So the answer will be 7/2. So we can see that the numerator is bigger than the denominator. So it's an improper fraction. So now what we're doing, we're changing mixed number to an improper fraction. So this is the first strategy, where we change we're changing the whole number to a fraction. And then we said if the number divides itself, the answer will always be 1. Where do we get the denominator? We got a clue from our fraction. Our fraction was 1/2. That's why when we wrote 3 in fraction, we have 2/2 plus 2/2 plus 2/2. So we have 2/2 times 3. In other words, we have 2/3. So 2/2 is equal to 1. 2/2 is equal to 1. 2/2 is equal to 1. That's a 3. And then the last fraction will be 1/2. So if we're adding all the 2's, the numerators, we have 3 2's. That makes 6 plus 1. Where do we get a 1? From 1/2. So the answer will be
6/2. So strategy number 2. The other way of doing
Just-
it, we have,
Leka,
okay?
just slow down a little bit. The guys are saying that you're going a bit too fast. Please just slow
Oh,
down a
okay.
little bit. Thanks.
Okay, so thank you for that. Okay, so we're saying we're changing mixed number to an improper fraction. On the last slide, we were doing improper to a mixed number. Okay, I said we're having a question, we're having our question 2, 1/2. But I want us to use one of the examples that we did. We had 7, 1/4. That was our answer when we're doing one of the examples. It was 7, 1/4. I want us to change it back to a improper fraction because now we have a mixed number that is 7 and 1/4. So first, this is the first strategy, or this is how you can do it. There are many ways of doing it. I will only show you 2, but now I'm still repeating the first one because some of you didn't hear me. Okay, because I was talking too fast. Okay, let's continue. We have 7, 1/4. So we're writing 7 as a whole number. We're changing 7 to a fraction. And then we said, if the number divides itself, the answer will always be 1. So now let's write 7 as a fraction. We will have 4/1. Where do I get a 4? Our question says 7 and 1/4, meaning that 7 and a quarter. Ne? So it's 7, 1/4. That's why when I'm writing my 7 as a fraction, I'm using a denominator of 4. I got the 4 from that quarter that is next to a 7. So we have 4/7. We have 4/7 we have 4/4, 4/4. We're gonna write 4/4 7 times because 4/4 is equal to 1. So we have 4/4 plus another 4/4 plus another 4/4. So it's 1, 2, 3, 4, 5, 6, 7. So we have 4/4 7 times. We're going to write 4/4 7 times. That gives us a 7 because 4/4 is equal to 1. 4/4 is equal to 1. I'm repeating myself so that we can all be here. And then now we have to add 1/4. Remember, our question was 7 and 1/4. So now we're going to write 1/4. After we wrote 7 4/4. When I say 7/4, I mean we wrote 4/4 7 times. So we have 1, 2, 3, 4, 5, 6, 7 4/4s. That gives us a 7. So all you do now, you just add all those 7. So it's 4, all those 4s. So it's 4 plus 4, 8 plus 4, 12, 16, 20, 24, 28, plus that 1 of 1/4. The answer will be 29/4. So we change 7 1/4 to 29/4. 7 1/4 was a mixed number. Now we change our mixed number to an improper fraction. That's the other way of doing it. Let's try the one that I think it's easier to understand. The strategy number 2 of changing an improper fraction, of changing a mixed number to an improper fraction. Let's do. I'm going to use the same example, 3.5. Let's all write 3.5. Let's hope everyone is writing down 3 and 1/2. That is 3.5. We want to change our mixed number to an improper fraction. This is how you do. Let me read it down right now. Let me read it to you. I wrote something down. We take the whole number, we multiply it with the denominator, then add the numerator. Let me say it again. This is strategy number 2. When you're changing your mixed number to an improper fraction, we take the whole number, we multiply it with the denominator, then we add the numerator. Let's try it out. So we take our whole number, that is 3. We multiply it by the denominator. In this case, our denominator is 2. Then we add the numerator, that is 1. So the answer will be 7 over 2. You don't lose your denominator. You're still using the same denominator. Our mixed number was 3.5. In other words, was 3 and 1 over 2. And I'm saying now, when you're changing it from a mixed to an improper fraction, you take the whole number, you multiply it with the denominator, then you add your numerator. So in our example, you say 3 multiplied by 2. Remember where we got a 2? It's our denominator. And then you add 1. Where did we get a 1? Is that our numerator? So the answer will be 7 over 2. Okay, so I had few examples that I wanted us to go through. Let's only do the last one. 10, let's say we were given 10 and 2 over 3. That is our question. They gave you a question, a mixed number, and then say change it to an improper fraction. What you do, you take your whole number, you multiply it with the denominator, then you add a numerator. So our whole number in this question, that is 10 and 2 over 3. It will be 10. We take our 10, that is a whole number. We multiply it by our denominator. So in our case, our denominator is 3. Then you add your numerator, that is 2 in our question. So the answer will be 10 times 3. That gives us a 30 plus a 2. So the answer will be 32 over 3. So meaning that if we're changing 10 and 2 over 3 to an improper fraction, the answer will be 32 over 3. Now I'm going to ask my host to unmute you all so that you can ask questions.
Unmuted all.
Thank you, man.
Lost. Confused.
Which one? Where were you lost? Okay.
Where's the board?
We need the board. I'm very lost. Like serious.
Yes, we are
We get the board.
Guys, the board will be back with your next presentation. There was some technical difficulties. Teacher did try and advise as best as possible without the material at hand. It would be back on the next presentation. Okay.
Okay.
Hey guys, Luleka will be back. Enjoy the rest of your days. We will be ending this presentation now. Thank you.
Bye-bye.